I wrote this book last, and I wrote it knowing it was the floor the other 16 had been standing on all along. The cosmological quest has walked the world of the measurable few for a great many miles of dark water. The arrow of time in the thermodynamics volume, the rigidity and magnetism of matter in the condensed matter one, the color of a dying star, the disorder of a plasma, and every one of those journeys ran quietly on an engine I had never quite turned to face. This 17th volume turns and faces it. It is the mathematics of the many, the account of how the reversible, time-blind motion of countless particles becomes the irreversible, reliable, one-way behavior of the matter they compose. Where earlier books reported the laws, this one derives them, and in deriving them it keeps two promises I had made and set down. The promise from volume 15 of a machinery beneath the engineer's gauges, and the promise from volume 16 of the mathematics by which a swarm of identical dumb parts organizes itself into a new and lawful whole. I stated the central miracle at full strength before I let a single equation loose in the cabin, because familiarity has worn its strangeness almost smooth, and the strangeness is the whole point. Take a room of ordinary air, some 10 to the 23rd molecules, each obeying laws that keep no arrow. Run the film of any collision backward, and you see another perfectly lawful collision. Now do the audacious thing the method demands. Refuse, on principle, to track them. Do not follow, count, ask not what each molecule is doing, but how many arrangements would look, to my crude instruments, the same. And out of that principled refusal to look comes temperature, exact, pressure, exact, the entropy on the gauge, and the second law itself, the arrow the underlying molecules do not contain, probability going in, certainty coming out. That a matter of mere counting should command the physical world with the authority of iron is, to me, still the most astonishing single fact in physics. The second law is not a law of dynamics, it is a law of counting. The book is built in 7 movements. The first lays the bridge itself, probability, phase space, the fundamental postulate, and the ensembles that are the method's working tools. The micro-canonical, which counts the states of an isolated system. The canonical, which sets a system at a temperature. And, in the second movement, the grand canonical, which lets particles as well as energy flow, and hands us the chemical potential. There I raise the partition function to its proper place as the master key, that single sum over states from which every thermodynamic quantity falls out by a stroke of differentiation, and I follow classical statistics to exactly the point where it breaks and demands the quantum. The third movement is quantum statistics let loose in its worlds, the Fermi gas of electrons that explains metals and holds up dying stars against their own gravity, the Bose gas and its strange condensation, the black body radiation law that founded quantum theory outright, and the phonons that give a solid its heat capacity. This is the machinery at its first triumphs, and none of it is in doubt. Where I invoke it, I lean my whole weight without a tremor, and I mark it, as the whole series marks its claims, as established science in the strongest sense the word carries. The fourth movement is, to my mind, one of the summits of 20th century thought, and I gave it a part of its own. Real matter interacts. The ideal gas is a lie of convenience. So I take up interacting systems, and then the Ising model, the fruit fly of the field, a grid of spins that want to agree with their neighbors, from which Onsager wrung an exact solution in 2 dimensions that stands as one of the hardest and most beautiful calculations physics owns. From there to phase transitions and critical phenomena, where a substance changes its whole character at a single temperature, and where, at the critical point, wildly different materials behave identically. The same numbers, the same exponents. Why should a magnet and a fluid share their arithmetic at the knife edge? The answer is Kenneth Wilson's renormalization group, which explains universality by showing what survives when you blur a system out to ever coarser scales and ask what does not change. I credit it as established, and I do not pretend it is easy. It is one of the genuine intellectual achievements of the age. The fifth movement goes down to the foundations, and here I ask the reader to hold a distinction sharper than usual because it is the spine of the whole audit. There are two questions one can ask of statistical mechanics, and they have wildly different answers. The first is, does the machinery work? The second is, why does it work? On the first, I will stand anywhere and defend any weight. On the second, I must tell you plainly that after a century, the honest answer is that we do not fully know. So, I ask what entropy really is. Holding Boltzmann's counting, Gibbs's ensembles, and Shannon's information side by side, I take up the arrow of time and the roots of irreversibility, and I refuse to hurry the reader past the vexed question of ergodicity, the assumption that a system, given time, visits its states in the right proportions so that time averages equal ensemble averages. It is a beautiful assumption. It is also, for essentially every real system of interest, unproven, and in its strict form known to be false, where the Cam theorem preserves islands of order that never mix. Ergodicity, mixing, typicality, coarse graining, Jaynes's information theoretic inference, and for quantum systems, the eigenstate thermalization hypothesis are live, competing, and unreconciled. That is a genuine frontier, a century old and still open, and I graded it as 1. A method can be the most reliable in all of science and still not fully understand itself. Statistical mechanics is precisely that method, and only a coward's book would pretend otherwise. I close the movement on the modern revolution in fluctuations, the response relations and fluctuation theorems that turned the second law from a mere inequality into an exact equation about the odds, and on the exorcism of Maxwell's demon, whose sorting imp is defeated on this method's own terms once Landauer and Bennett showed that erasing the demon's memory pays the entropy back in full. The sixth movement walks the hardest and most modern frontiers. Statistical mechanics far from equilibrium, the physics of networks, disorder and complexity, and the two hardest children of the whole method, charged and gravitating matter. Here the series electric thread runs for once straight into the deep water where it belongs. A plasma is nothing but a statistical mechanical system of charged particles, and the Coulomb force ruins the quiet assumption of short range that makes ordinary counting tractable. Energy stops being additive, the thermodynamic limit turns subtle, and the ensembles can genuinely disagree, exactly as they do for self-gravitating systems. Yet the method rises to it. Debye and Huckel showed how a plasma screens its own long-range force. Landau drew from it the exact, dissipationless wonder of Landau damping. I credit that depth in full. It is the honest core the electric thread was always reaching for, and with the same pen I mark where the credit stops. None of it licenses a loophole in the second law. No plasma dressing resurrects the demon or a free energy engine, and any such scheme is declined here by name as a claim the evidence will not bear. The seventh and last movement asks the deep question the method has never fully answered, why it works at all, and follows the reach of the method out to markets and mines and black hole entropy, and then renders the verdict. Two ledgers kept unblurred to the final page. On the one side, the machinery, the ensembles, the partition function, Boltzmann's and Gibbs's entropy, the quantum statistics that run the stars, Planck's law written on the sky, Onsager's exact Ising conquest, Wilson's renormalization group, the modern fluctuation theorems, all load-bearing, all defended without apology. On the other, the foundation. Why the counting commands the world. What happens far from equilibrium. Whether the world is truly ergodic. All a century's unfinished business, told to the reader as unfinished. To stand firm on the first and stay candid about the second is the whole method of this book. It is a strange thing to write the last foundation last, to reach the end of a long voyage and find the ground you are finally standing on was under every mile of it. The stove ticks, the lamp is low. This is the last of it, and I hand it over as I have handed over all the rest, a clear grade on every claim and the willingness to the very end to be told I was wrong.